right, this problem we're going to do together is on my for my Calculus 1 class optimization review lab. And I want to do a couple problems with you because I really like them and I like how they're set up. So here is a rectangular storage container with an open top is to have a volume of 10 cubic meters. So rectangular is important. It's a rectangular storage container. So let's kind of set it up a little bit. So there's my rectangular storage container with an open top. So we're just going to leave the top open. Is to have a volume of 10 cubic meters. Okay, that's my volume. The length of the base is twice the width. So I'm going to call the width x and the length is going to be twice of that, which is 2x. The material for the base costs $10. So it costs $10 per square meter. Oh, so this is meters, square meter, sorry. And material for the sides cost $6 per square meter. So it must be not as substantial. Find the cost of the materials. Well, first of all, I called the height H because they didn't really tell us anything about it. So I'm going to call the height H. And I'm going to set this up so I have my constraint. And my constraint basically is my volume, right? Because they told us it has to be 10 cubic meters. My objective is to find the cost of the materials that are the cheapest or the minimum cost. So it is minimum cost is the objective. So our constraint equation has to do with volume. And basically, I know the volume of a rectangular shape is length times width times height. So I have the volume is going to be x, 2x times x. It doesn't really matter how I do this because we're going to multiply them all together, but 2x times x times h. So the volume is 2x squared h, and I know it has to equal 10. All right. What I would suggest is that you solve for h, because if you could solve for x, but you'd have to do a square root. So I'm going to divide by 2x squared. So when I do that, I have my h is 5 over x squared. So I just solve for h so I can do everything in one variable. And this is what I'm going to actually put over here in my objective after I do my cost equation. So I'm going to do the cost equation in green. So my cost equation is the cheapest material. So you're talking surface area with money. So we're talking about the base, and the base is 2x squared, the area of the base is, and it costs $10. So I'm going to say $10 times the 2x squared. Okay. Now this one's a little bit different because if I were to look at the side, so let's look at this side right here. This side and this side over here, so I'm going to kind of go this right here. This side over here are the same because it's rectangular. And if it's rectangular, I know the area of that side is XH, but I know what it costs is $6 times, let me move this up, times XH, but there's two of them. So I'm going to say $6 times 2XH. And then I've got to do the other side plus $6. Now the front and the back are 2x times h, so it's going to be $6 times 4xh. So that's my cost equation. I'm kind of squished over here, but that's basically what it is. So I'm going to kind of move this down a little bit so I have more room to write. So basically my cost equation is going to be, all right, let's multiply it out, 20x squared plus 12xh plus 24xh. And then I'm going to combine those some more. So my cost equation, so I'm just going to kind of go over here because I have more room, is going to be 20x squared plus 36xh, okay, which is cool. Now I'm going to take this, what I just solved for h, and I'm going to put it in that spot so I would have my cost equation be in all one variable. So my cost equation is going to be 20x squared plus 36x times 5 over x squared. So one of these x's are going to kind of cancel out here. So my cost equation is going to be 20x squared plus 180, and it's going to be over x, but I'm just going to bring it up as x to the negative 1 because that's what we're going to do the derivative. So here basically is my cost equation. Now I'm looking for a minimum cost. So I've got to do f prime of x is equal to 0, which is going to be c prime in this case. So let's make c prime is going to be 40x minus 180, okay, over x squared, or x to the negative 2, and we're going to put it equal to 0. Now, when you get it like this, I would put this over on this side, so you have 40x equals 180 over x squared, cross multiply, so I have 40x cubed equals 180, divide by 40, x cubed equals 9 over 2, take the cube root of that, so raise each side to the 1/3. When I do, I get x to be 1.65 meters. So that's what it's saying, that x has to be a 10 cubic meters for that. So now we're going to check all this out. Remember, we have to do the C prime bar to make sure that really is a minimum cost. So I'm going to put 1.65 here. And remember, when you do that and check that, you should be looking at this in your calculator. So if you go to the left, and you should really practice doing this, you're going to get some minus signs here, negatives and positives. So this really is a minimum cost. So that's our first derivative test. So it just says find the cost of the materials. So basically, what you're going to do now is actually plug this into the cost equation, which is this right here, right here. So I'm going to take, let me add some more spots to this. Take the cost. So I've got C of 1.65 meters, okay, is going to equal 20 times 1.65 squared, and then it's going to be plus 180 all over 1.65 squared. Okay, because that's what your cost equation is. And when you do, you'll find out the minimum cost. So make sure that you put it in your calculator and you round it to 2 decimal places.